Hey there, we're the IvyWarriors First Tech Challenge team number 16716, and our goal is to help First LEGO League teams gain a thorough understanding of SpikePrime. Today, we'll be discussing the basic movement options that SpikePrime offers. As mentioned in the previous video, SpikePrime provides more precise movement for the robot due to its use of plastic wheels in comparison to EV2's rubber grip on its tires. While programming, SpikePrime first asks for you to select the motors with which to move. Similar to EV3, you can select to move one or two motors at once, and you can choose the motor pair option to rotate two motors at once. When it comes to movement itself, if you have an exact distance that you'd like to move, SpikePrime has another feature that lets you move that distance. After measuring the distance of one wheel rotation, or the circumference of the wheel, one can input that measurement into SpikePrime and travel exact distances. Also, you can set the speed and braking point at which the motors will run in your program too. Let's look at a few examples of these implementations. Here's an example of a word block program to show some basic movement. First, let's go ahead and make a word block program. Now, let's start off by setting the movement speed, so this program knows exactly how fast we want our robot to move at the start. Next, we have to let this program know which are our movement motors, which two motors are actually driving the robot, and that's what we're doing here, setting it to A and E. Next, we can use the single motor block to declare that motor C, our arm, should be rotated to a 180-degree position. Following that, we can do another move of the entire drivetrain 10 centimeters forward, followed by another movement of the single motor by degrees. Single motors don't have to be rotated by degrees, but this is just an example. Next, why don't we do a turn? So we should probably set our speed to 25% to be a little more precise. Then we can do a turn using time. So if we start moving clockwise and then wait about 1.25 seconds, that should be about 180 degrees turn. And then we have to make sure we stop moving the drivetrain, otherwise it's just going to keep on spinning. Now that we've stopped, we can end off the program with another movement backwards by 10 centimeters. This program is just a small demonstration of a couple of the options you have for moving motors. We have movement by degrees, as shown with the single motors. We have movement by distance, like the 10 centimeters with the motor pairs. And we even have movement by time, as seen here when we turn the robot. According to this program, the first thing the robot should do is move the arm and then move forward 10 centimeters. After that, it should move the arm again and then spin, followed by another move backwards. The rest of these blocks are just indicators to tell speed, time, and distance. Here's an example of implementing the one motor rotation block. So of course, at the start of every program, we have to define first our movement motors, which are A and then E. Next, we're going to go ahead and set the speed, because the program and the robot both need to know at what percentage of the total speed it needs to run. So we're just going to keep it to the default of 50. Now we're going to use the important block. This is going to allow us to move exact distances. So we've measured, let's say an example of about 11 inches of a one motor rotation or circumference of our robot's wheels. Now, if we wanted to move, let's say 20 inches, all we have to use is this block, and then we'll just be able to input these values, and we're done. Now, the robot is going to move 20 inches when we run this program. Now, here's an example of another MicroPython code. We're going to go ahead and recreate what we just built using the word blocks set up through MicroPython. On MicroPython, there is also an API listed on the side as seen here. The API listed as a knowledge base indicates every aspect of SpikePrime's MicroPython. Here's an example. Under the buttons class, we can look at the wait until pressed method and figure out exactly how to write it and how it can be implemented, with some comments helping explain it even more. Now first, let's just create a new project. And let's start by defining our drive motor pair. So we go down here and we set a new object called the drive motors to motor pairs A and E, because those are our motors themselves. Now here I'm going to go ahead and define one of our single motors, motor 1, and it's motor C. Also down the road, if you ever need to write any comments to remind yourself or any notes to remind yourself of what your program is doing, you can use comments, which are hashtags followed by explanations of the code. These codes are not read by the computer. Next, what I'm going to do is I'm going to start off by moving the first motor down to the 180 degrees position. All of these parameters must be filled for every situation or instance. Otherwise, it doesn't know what exactly you want the robot to do. Now, after we've moved the motor, we're going to move the drivetrain itself 10 centimeters forward relative to our wheels. Next, we're going to, again, move our singular arm motor back up to the 270 degree position, and then we're going to follow that up with a movement of the drive motor at a turning speed now, because steering is equal to 100, at a speed of 25, moving at 10 centimeters. And then again, we're going to go ahead and move forward 10 centimeters. So let's see what this code ends up doing. Thanks for watching this FLL SpikePrime video. If you have any questions, leave them in the comments section below. We'll see you in the next one. Thanks.